Hello friends, how about looking at this number line in a specific way? This E is the elementary charge, that is the charge on a proton or a charge on an electron. So the value of E is 1.6 into 10 to the power minus 19 coulomb. So this one is 1E, this one is 2E, this one is 3E, this one is 4E, where E is the elementary charge, or you can say the charge on a proton or charge on an electron. So this much of charge points to this much of charge. This much of charge points to this much of charge. This much of charge points to this much of charge. This much of charge points to this much of charge, and goes on. So the point here is that only this much amount of charge is possible. That means only this much amount of charge is possible, or this much amount of charge is possible, or this much amount of charge is possible, or this much amount of charge is possible, and goes on. Is that clear? Now this region of space explicates that the charge is not possible in this region of space. It expounds that charge is not possible in this region of space. Charge is not possible in this region of space. Charge is not possible in this region of space, and goes on. In other words, you can say that any charge is the integral multiple of elementary charge. Any charge, let's see this charge. So this charge is the integral multiple of elementary charge. This charge is the integral multiple of this elementary charge. This charge is the integral multiple of the elementary charge, and here the elementary charge, that's the 1E, and the elementary charge here is itself. This one is the integral multiple of elementary charge. So a charge always occurs in discrete units. A charge always exists in discrete units. It rejects the continuum. The charge, if you say the charge that's equals to ME. So any charge in this universe is the integral multiple of the elementary charge, and this is the charge on an electron or a charge on a proton, where n is the integer and it takes the value 0, plus minus 1, plus minus 2, and so on. Fine friends, it doesn't matter whether it's negative or positive, whether it's negative 1.6 into 10 to the power minus 19 coulomb, negative 2 into 1.6 into 10 to the power minus 19 coulomb, negative 3e, that's negative 3 into 1.6 into 10 to the power minus 19 coulomb. So it doesn't matter whether it's negative or it's positive. Negative and positive just indicate the the nature of the charge. It just points to the nature of the charge. Is that clear, folks? So any charge in this universe is the integral multiple of the elementary charge. So if you look at this region of space, the charge is not possible in this region of space. If you will look at this region of space, the charge is not possible in this region of space. If you will look at this region of space, the charge is not possible in this region of space. Only this much amount of charge is possible. Only this much amount of charge is possible. Only this much amount of charge is possible. So the charge may be either E or some integral multiple of E. Is that clear? It may be E, the charge may be E or some integral multiple of E. Is that clear? So the smallest value of the charge that's possible is E. The smallest value of the charge that is possible in this universe is E, in fact, because E is the elementary charge. So let's have one more charge, that is 1.2 into 10 to the power minus 50 coulomb. So is a charge of 1.2 into 10 to the power minus 50 coulomb possible? So if the question here is a charge of 1.2 into 10 to the power minus 50 coulomb possible, how we will deal with this one? So 1.2 into 10 to the power minus 50 coulomb, it lies somewhere around this. Fine, it lies somewhere around this here. Is that clear? In fact, this is even less than this amount of charge. So it lies somewhat here. So we have discussed that this reason rejects the possibility of charge. 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 So this charge is not possible. And at the same time, we can infer that this charge is even less than the elementary charge. Fine. What's the elementary charge? Elementary charge is 1.6 into 10 to the power minus 19 coulomb. So this charge is less than the elementary charge. So this charge is, in fact, this charge, as a matter of fact, this is not possible. Is that clear? So whether it's negative 1.2 into 10 to the power minus 50 coulomb or positive 1.2 into 10 to the power minus 50 coulomb, it doesn't matter. But the point is that this amount of charge is not possible. Fine. This amount of charge is not, in fact, this amount of charge is not possible. Clear? Only this amount of charge is possible, or the integral multiple, some integral multiple of this amount of charge. Is that clear? This amount of charge, if we talk about this amount of charge, so this amount of charge is possible. This amount of charge is possible. It doesn't matter whether it's negative or positive. The point is that this amount is possible. This value of charge is possible. This value of charge is possible. This value of charge is possible. But the value that lies here, the value that lies here, the value that lies here, the value that lies here will not be possible as a charge. Is that clear? This value can't be taken for charge. This value can't be taken for charge. This value can't be taken for charge. So we cannot take any value for charge. The value should be the integral multiple of the elementary charge. This is in fact, as a matter of fact, this is the quantization of charge, and it explains that the charge is quantized. It exists in discrete units. It rejects continuum. So this is all about the quantization of charge. So let me discuss something about the quarks. We don't take quarks as elementary charge because on account of the fact that these quarks do not exist in free state. And the only elementary charge that is going to exist in the free state is this one. Is that clear? That is a charge on a proton or a charge on an electron. Thank you very much. Do subscribe and share the same.